most effective setup detects an attack in real time, pushes narrowly scoped filters to edge routers within seconds, and places your most critical services behind an always-on protection. Everything starts at the edge of the network. The moment Deepfield Defender spots hostile traffic, it creates just a few filter rules and sends them straight to the routers, already forwarding those packets. That loop, from first sign of trouble to enforcement, typically finishes in under 30 seconds. For systems that can't tolerate even brief downtime, like authoritative DNS servers or payment APIs, many operators add an inline appliance in front of them. That appliance inspects every packet from the very first hop, eliminating even that half-minute exposure. Most attacks will fizzle out right there on hardware that you already own, with no detours for legitimate traffic. So to summarize, block the attack as close to the edge as you can, and put those never go down services in a permanent protective bubble. Scrubbers add protection, but their fixed capacity and the delay in steering traffic to them mean that they can be overwhelmed or sometimes late to the fight. A scrubber is a dedicated device, physical or virtual, that sorts good packets from bad. And because it is a finite box, there are always limits to what capacity it can handle. Today's record attacks are measured in terabits per second, volumes that even a single appliance or even a small cluster may not be able to absorb. To reach the scrubber, you usually have to redirect traffic with BGP, and those route changes can take a few minutes to propagate in some cases. During that window, the attack is already hitting your links. So the need to maintain hardware that you hope you never use. So the picture is pretty clear. Scrubbers are valuable, but they are not a cure-all. Treat scrubbers as a backstop. Their main limits are capacity and the time it takes to bring them into play. On-prem protection is fast and always under your control. Cloud protection can soak up larger floods, but adds a handoff delay and put a third party into the path. With on-prem mitigation, everything stays inside your own autonomous system. Detection fires, routers drop the bad traffic locally, and then legitimate traffic keeps the local path. You avoid the BGP shuffle, you keep the latency low, you retain control of data and logs. The trade-off is bandwidth. If the attack exceeds your inbound capacity, you can't shed it alone. That's where cloud mitigation helps. A provider with very high capacity links advertises your prefix, absorbs the flood, filters it, and then tunnels the remainder back. The downsides are the few extra minutes for routing convergence and the fact that inspection now happens on someone else's infrastructure. Many operators therefore keep cloud mitigation as a break glass option, useful, but only after local tools reach their limit. So in a nutshell, use on-prem for speed and precision, reserve cloud mitigation for really the major outsized events. Always On inspects every packet all the time, while On-Demand kicks it only after an attack is detected. In an always-on setup, traffic for protected objects flows through a mitigation device 24/7. There is zero detection lag, but you incur a small, constant latency hit and consume inspection resources when no attack is present. On-Demand leaves the normal path untouched until Deepfield Defender sees trouble. Defender then injects router rules or can swing the flow through an inline path. You can avoid day-to-day overhead, but you leave with that brief window where filters propagate. Most networks blend the two, always on for critical services, on demand for everything else. Always on buys immediacy, on demand saves overhead. You can choose per asset rather than adopting a one blanket policy. It layers fast edge filtering, selective always-on protection for critical services, and a cloud safety net for the once-in-a-blue-moon flood. First tier, dynamic filters at the edge handle 95% of attacks quickly and cheaply. Second tier, an inline appliance, or at least strict preposition rules, guards against high-value hosts around the clock. Third tier, a clearly defined trigger, instructs operations to divert traffic to a cloud provider if the local bandwidth is in danger of being overrun. Because each layer plays to its strength, you avoid single points of failure, keep false positives low, and pay cloud fees only when the situation really demands it. In summary, combine rapid local filtering, continuous protection of vital systems, and a cloud fallback in one coordinated playbook, and you'll be ready for attacks of any size.